All right, here we go.
Is that a water balloon?
Is this a water balloon?
Yeah. Is it supposed to be a water
So, on Friday, what did we decide? When you rub it with the fur, what's happening to the balloon? What is the fur doing?
Giving electrons.
Okay, so the fur is donating excess minuses. The fur is donating excess minuses to the balloon. So now what is the overall charge on the balloon?
Negative.
That's right, the overall charge on the balloon is minus, yes? What about the board? Does anybody rub the board?
No.
No, so what's the board?
Neutral.
Neutral.
What is
So how is it possible that the neutral balloon, or the charged balloon can stick on the neutral, board? Check your neighbor now. Okay, check your neighbor now. Okay. So what happens when you bring this minus balloon in? What happens when you bring the minus balloon in?
Pushes all the minuses away.
Okay, good. So it pushes these minuses away. Right? What does it leave the front side of the wall then? Positive, and it attracts, and Bob's wrong. Is that okay? That's part of our understanding. Cool. So here's the deal. So I have my little piece of Mylar. Now, this, on Friday we talked about, this is the fun fly stick. The fun fly stick will develop an overall positive charge on the wandy end, right?
Mm-hmm.
All right? Okay. Develops an overall minus charge on the wandy end. Okay. What's that? What?
Positive charge.
Positive charge?
You said a minus.
Sorry. I got a little distracted. I don't think this is going to work. That's work. Okay. Yes?
Mm-hmm.
Overall positive charge here? Cool. So this is a little piece of Mylar. It currently has a negative charge. I know it's negative because no one rubbed it and no one touched it.
You
Yes?
mean neutral?
Okay. What's that?
You mean neutral?
So I didn't get a lot of sleep. Clearly, not sleeping. Not sleeping, not sleeping. So the Mylar is negative, so or it's neutral. Here we go, ready? Okay, so this is positive, yes?
Yes.
So will this positive attract this neutral?
Somewhat.
It will, right? And we know that it will. Okay? Okay. So it attracted it at first, yes? And now what's it doing to it? All right, now it's repelling it. True? Okay? So that's the question is, get off of me. No! So clearly one was positive, one was negative, yes? All right, here we go. So how did that happen? Okay. How did that happen? Now, I would suggest you draw these things when I draw them. I don't care if you do or not. It does not matter. You do what you want.
Oh, I'm fried.
So here's the fun fly stick. Okay. Here's the piece of Mylar. What do we know about the Mylar? Nobody rubbed it, no before anybody touches it. What's its deal? Neutral. It's neutral, which means what do you know about its distribution of pluses and minuses? Right? Now, what happens though? If you bring this close to a positively charged object, what's going to happen? It's going to attract what?
The electrons.
So the minuses are going to move to the front, okay? The minuses are gonna move to the front. What does that mean? That means that the front of the Mylar is negatively charged, the wand is still positively charged. What's gonna happen to those? If this one's minus, the front of this is minus, and the front of this is positive, what's gonna happen? Is it going to attract it? It is, right? Well, what happens if it gets close enough to touch it? What's gonna happen if it gets close enough to touch it? Yes, Jacob?
The electrons go onto the fun fly stick.
So, if you can get them to touch, some of these minuses move over, yes?
Yes.
Now, this thing is really positively charged, yeah? So just throwing a couple on here, does it change the overall charge of this?
No.
No, but what happens to this thing over here? If you throw any of these minuses over, what happens now? Look at this whole thing over here. Now it's net positively charged, and what should they do after the touching?
Repel.
They should repel. Is that what we saw? Is this electron transfer model okay for this? I'm okay for that. You okay for that? Okay. I'm cool. I'm good with that. All right. We worked with this on Friday also. So, styrofoam.
Yes.
I'm going to rub it with the bunny fur.
Once you rub it for 5 years.
Okay. I rub it with the bunny fur. So what did I do? Anytime you rub something with the bunny fur, what happens to it?
It becomes negative.
Okay, so I donate some excess minuses on there, so this thing is excess minus. Is that cool? So now I'm holding it by the styrofoam cup here so I don't transfer any electrons to it or from it. If I bring this close to here, what does it do to all the minuses in the pie plate?
What if you let go of the styrofoam?
Okay? This thing is minus down here, true?
The rim.
What's it going to do to the minuses in the pie plate?
It's going to go the
Is it going to attract them or repel them?
Repel.
It's going to repel them, so I'm going to put it here. All right? Now, if they have some place to go, if I'm going to bring my finger close, listen closely. Oh, my Lord!
You said it didn't hurt.
Ah, just wasn't ready for it. Did you hear it?
Yes. Yeah.
Was that electrons jumping through the air to my finger?
Yes.
Yes, it was. So now, if electrons have jumped through the air to my finger, they left this thing. If they left here, what should this be? Positively or negatively charged?
Positive.
It should be positively charged, true?
Mm-hmm.
Okay. So, the fun fly stick and the Mylar are both positively charged, true?
Yeah.
Whoa.
It's
dude.
So is everything here positively charged?
Yes.
Yes.
Is that okay with you guys so far? So that's another methodology. It's just so fun.
You need to touch the ceiling.
Remember, the ceiling is neutral. So because the ceiling is neutral and the Mylar is charged, right, it pulls some of the minuses toward the front of the ceiling, and the minus of the ceiling attracts the positive of the Mylar, and it's going to stick. Is that okay? Now, here's the thing about this, though. When I brought this close,
You said it didn't hurt.
it doesn't. It just is shocking. Okay? Now,
My God.
I took some electrons off of this. This is now positively charged, true? All right? Now, what if I touch somebody with it?
Oh God, please don't.
Did you feel it?
Yeah.
So what happened now? What did he do? He donated the electrons back. See, because we are large compared to this thing, we are what's called a ground. Okay, we are the ground. And so the ground can donate or take electrons away as many as you want without changing your charge. Because I'm literally on the ground. You see this? So the ground can donate or take as many electrons away. So right now, I'm a ground, so I can take. Okay, so I can put this on here. Take electrons away, but it doesn't charge me because I'm the ground, right? Okay. Right? And now he donated them back, so now we're neutral again.
He's just like, no.
Is that cool? So far, so good? All right. Now, this little ball, it's called a pith ball. They used to be made of this stuff called pith. Now they're just made of styrofoam with a little bit of conducting or a little bit of it's like graphite paint on it.
So, what was pith?
So pith is the stuff that you it's between the peel and the fruit of like an orange, that white stuff.
Oh, yeah.
And if you dry, it's pretty strong. Like explorers used to have that called a pith helmet. You ever heard of that? Pith helmet? It's the kind of like a safari hat that you would see in the old movies. Pith helmet. That's what we call it here. Is it? I think so. Roast. I have to take my sweatshirt off. I don't sleep. I'm just a disaster. Nope, can't do it.
You want someone else to do it? You want it squared up?
No, you don't hold on.
Or squared up?
Okay.
I forgot what his next.
Okay. So this thing is overall positively charged. Will it attract this neutral ball?
Yes.
Yes.
It will, right? In fact, it's going to attract it.
Me.
Did it attract it at first?
Yes.
And now it repels it, true? Why?
Because it got here.
Because they touched. So what happened? This is a multi-stage process. Okay? This is a multi-stage process. So, stage one. First thing we did was rub the pie plate. I'm sorry, rub the styrofoam. And it left the styrofoam overall negatively charged, yes? Okay, and then we're going to bring the pie plate close. Cool. What happened to the pie plate? The minuses move up here. Then you bring the finger close. Okay. You bring the finger close, and what happens? Since the minuses have moved up, it pushes these minuses back, and it leaves the front of the finger positively charged. And then you touch it, and what happens? Some minuses move over. Is that cool? But the hand doesn't care because this is the symbol for ground. The hand doesn't become charged because it's a ground. Is that all right? So now what we have is we have a positively charged pie plate. So the pie plate is overall positively charged. True? Okay. If I bring it close to this ball over here, what happens if I bring it close to this ball? Do some of the minuses move in the ball? Where do they move? They move to the front side, yes? Okay. So if they move to the front side is negatively charged, this pie plate is positively charged, so what are those two things going to do to each other? It's going to attract, but if it swings and gets close, what actually can happen? A minus or two can move over, true? And then if you have this electron transfer over here, what does it leave the ball then? It leaves the ball overall positively charged, and if the pie plate is also positively charged, what should they do? Repel. Are you with me on this? You see how this thing goes?
Yes.
Okay. See how this thing goes? There's one more. There's one more, and then we'll move on with our lives. So this is actually kind of interesting to me. So I'm going to... Okay. So right now, the pie plate is positively charged because I pulled the electrons off. True? If I bring this close, it should attract it.
Wow.
Okay?
It does.
Kind of a joke.
It does. I mean, you got to get close. It's related to the distance. But here's what I'm going to do. I'm going to try to do this here. I don't know why I just switched sides. That was so weird. I'm going to bring this close, which means it's pulling the minuses to this side. What does that do to the far side, though?
Makes it positive.
It makes it positive. So I'm going to touch the far side. I'm going to touch the far side. And what that's going to do is, because the far side is positive, it's actually going to pull some electrons from my finger. Ready? So I'm going to bring this close so it's attracting.
Whoa.
Now, It was fast, we're gonna have to do it again. But what happens is, this pi plate is positively charged. If I touch the back side, it's donating a bunch of minuses to the thing, and all of a sudden, the ball is now net minus. And so how does it see this thing now? It's much more attracted to it because the more charge you have, the more attracted it is. Okay, so let's watch it again. I'm gonna bring it close. You see that happen? In fact, did you see it move toward my finger this time? That was
Yeah.
cool. So I'm gonna bring it close.
That was really cool.
You with me on that? Now, the problem is it hits there, right? It gets attracted, it hits there, takes on a bunch of, or donates a bunch of those excess electrons, and now gets repelled because now it's positive, so it swung away and hit my finger again. Did you see that? Let's do it again. Oh man, I grounded on it. So, okay?